In this video, we're going to look at indeterminate differences. I realize now that I've been spelling that word wrong my entire life. And indeterminate differences have the form infinity minus infinity. Okay, so our goal, the key idea is to change the way it looks, And there's a couple ways that we could do that. You could either put it under a common denominator, a common denominator. Another thing that you might try is if there's logarithms, you could use the law of logarithms. Use law of logarithms. Okay. But both of these really involve changing the way it looks so that we can, you want to put into either 0 over 0 or infinity over infinity, and then we want to use L'Hopital's rule. Okay, so let's take a look at an example. The example I had in mind for you today was the limit as x approaches pi over 2 from the negative side of secant x minus tangent x. Okay. Now, if we were to look at this, what you would find is that when you take the limit as x approaches pi over 2 from the negative side of secant of x, you're going to get infinity. And the same thing happens when you approach pi over 2 from the negative side, you're also going to get infinity. So we have this infinity minus infinity situation, which is a classical indeterminate difference. And the way that we are going to change the way this guy looks is we are going to use our trig identities. Okay. Now, I'm going to write my limit as the limit as x approaches pi over 2 from the negative side. We know that secant of x is just really 1 over cosine of x, right? That's the reciprocal identity. And when I look at tangent, we know that tangent can be rewritten as sine of x divided by cosine of x. That's the quotient identity. So when I rewrite it using trig identities, I can see that I do have a common denominator. So I'm really putting it under a common denominator. I didn't use the law of logarithms. I used trig identities in this particular case. And now that I have a common denominator, let me rewrite this as the limit as x goes to pi over 2 from the negative side. This will be 1 minus sine of x in the numerator. And in the denominator, we're going to have cosine of x. Okay. Now we know that sine of pi over 2 is 1. So this means you're going to have 1 minus 1. That's going to give me a 0 in the numerator when I plug in pi over 2. And we know that cosine of pi over 2 is going to be 0. So we get 0 over 0. This is the classic scenario, the basic indeterminate form where I can use L'Hopital's rule. So I'm going to use L'Hopital's rule. So I put an equals with a little LH on top to indicate we're using L'Hopital's rule. I got the limit as x goes to pi over 2 from the negative side. And I'm going to take the derivative of the numerator. So the derivative of the numerator is the derivative of 1, which is 0, minus the derivative of sine, which is cosine. So we'll get minus cosine of x, and that's the numerator. For the denominator, the derivative of cosine of x is negative sine of x. Okay. Now let's see what happens when I plug in my pi over 2. So this time, cosine of pi over 2, we know is going to be 0. and sine of pi over 2 is going to be 1. So I end up with 0 over 1, which is just 0. So our final example, or the final answer for this example is 0. All right, everybody, take care.